So welcome everyone. My name is Doug Cook. I'm a NOFAMAS board member. It's my pleasure to welcome you to a look into land and sea-based aquaculture with Erich Berghahn. Erich graduated from the University of New Hampshire in 2017 with a bachelor's degree in marine biology. He has been working for Michael Chambers at New Hampshire Sea Grant for 6 years as an aquaculture project manager. Erich loves being on the water and enjoys the constant problem solving of aquaculture, especially ocean-based aquaculture, as things rarely go as planned. And before we jump in, I like to go through our slides here to acknowledge that here at NOFAMAS, we're strengthening our commitment to racial equity and justice by examining our whiteness and dismantling systems of white supremacy that are part of many dominant systems, including our agriculture and food systems. We honor the indigenous land stewards who are the original occupants of this land that we're currently living, farming, and residing on. And so please use this map, this interactive land map, to find the area where you live and work and learn more about the historic stewards or the original stewards of this land. And then we invite everyone, looks like it's loading. We want to call on everyone, especially our white allies and co-conspirators, to a call to action to assist BIPOC-led organizations. These actions are listed here on this slide. So you'll see this again throughout the conference and throughout all of our conferences moving forward. We are holding a couple of spaces for Spanish speakers and BIPOC members, so we hope that you will enjoy and use those spaces. As well, we have a couple of Zoom norms here that are pretty much the straightforward ones. When it's your turn to speak, you can go ahead and come off of mute, and then just remember to go back onto mute to preserve sound quality for everybody. As well, please use the chat feature to enter questions as they come up, as you think of them, and then I, as moderator, will bring them in to the event as appropriate. As well, we want to thank all of our sponsors who continue to support our work and to make a lot of our events a success, like this one. So please take some time, learn more about them, thank them for their support, and check out some of their items that are here in the online auction, which is live until Sunday. So keep your eye on those things that you are bidding on, because they might, you don't want them to get away from you. As well, check out our virtual vendors. They have some nice discounts for all of our participants. And before we do get started, I also want to say my thanks to the New England Biolabs Foundation. With support from the New England Biolabs Foundation, NOFAMAS is hosting a year-long series of events on regenerative aquaculture and regenerative ocean farming as it relates to the North Shore of Massachusetts, and it's in this region. So with that end, we're exploring the possibilities and limitations of regenerative ocean farming in this region. So we're just really excited to bring all of these events together, starting with these 3 here at the winter conference. So be sure, if you missed any, to go back and watch some of the recordings. As well, stay tuned for more online events and also hopefully some in-person events where we get to gather on the farm or near the farm if we're not out on the water. And then with that, it's definitely my pleasure to introduce Erich. Thanks, Erich, for joining us. You're welcome to take over screen sharing.
Okay, thank you very much, Doug. So let's get started here. Should be good to go.
Yeah, that looks good.
So I am here to talk about the various types of aquaculture that I've been involved with through the University of New Hampshire and New Hampshire Sea Grant. I've been working for Michael Chambers. We do a variety of things, whether it's seaweed farming or, as you can see from the picture here, trout. We do mussels. We work with some of the oyster farmers in the area. We're starting to try out some scallop aquaculture. And I also have messed around a little bit with some land-based aquaculture and recirculating systems. We did a few years of research trials with biofloc shrimp, as well as just constructing acclimation systems for the rainbow trout before we would bring them to the ocean to make them steelhead trout. So I guess this presentation is mainly covering the ocean aquaculture, and then I'll have another shorter presentation after that talks about the shrimp aquaculture. Partially through this presentation, there is a video that we're going to try to play here that we have on YouTube. So that should hopefully go smoothly. So let's get started. So the first project that we've started here, it's multitrophic. You'll see IMTA. So that stands for Integrated Multitrophic Aquaculture, which is a long way of just saying we grow multiple species in one platform. So some acknowledgements to UNH professors and researchers and students and industry partners. We work with fishermen a lot. We sell a lot of our products to seafood markets locally here and sometimes to Boston or Portland. And then the variety of permitting agencies to even allow us to do everything that we have been doing, as well as the grant providers. So why have marine aquaculture? I guess a lot of people are aware, the oceans have been getting fished for a long time. We cannot continue to fish them the way we have been. So there needs to be another way of providing seafood, because many people love eating fish or shrimp or whatever it is. So currently the US is importing anywhere, depending on what statistics you're looking at, between 80 to 90% of all seafood in the country. Whether it's grown in the US or caught in the US, a lot of it gets shipped overseas for processing, handling, packaging, whatnot, frozen, and then sent back to the US. So it's a trade deficit of anywhere between 14 to $18 billion, depending on the figures. And so there's a large push more recently in the US to have more domestic production of local, sustainably grown seafood. So that's kind of where a lot of our, I guess my boss's drive and grants have come from for many years. It's trying to start fulfilling the bottom part of that process before commercialization of systems. So as I had mentioned here, IMTA is just the Integrated Multitrophic Aquaculture. So the whole concept here is you have finfish in a net pen, and then around this net pen we have mussel droppers right here, so shellfish, and then we have kelp as well, seaweeds, to uptake the nitrogen that is produced from the fish, because no one wants to be adding nutrients to the river. So instead, to get this whole project permitted, one of the first issues we ran into is, the Piscataqua River already has a lot of nutrient loading, specifically nitrogen. So they were very strict in the beginning and said anything that's going in the water here needs to not be adding nitrogen. Otherwise, they just didn't want to even consider it. So my boss did a whole bunch of research and nutrient analysis and came up with this model. Is this video grid in the way of the PowerPoint? I can't.
You can see your PowerPoint just fine.
Okay, perfect. So yeah, so he had to do a whole bunch of nutrient analysis and then basically prove that the fish in the pens is not going to be adding nitrogen to the river. So we have to follow very strict requirements with DES, New Hampshire DES and Fish and Game, to make sure that nothing is going wrong with this system. So we do benthic surveys underneath the system before we do any grow outs of fish, and then we do surveys under the system during the grow outs of fish, and then we do one after as well. So we take core samples to get them submitted for analysis. We do water samples, and then they occasionally come out too, just to observe and make sure things are as they should be and nothing's going wrong. So in order to fulfill this nitrogen, have a nitrogen neutral system, it's a 3-to-1 ratio. So for every 1 ton of fish in the system, we need to have 3 ton combined weight of kelp and mussels. So the mussels will take up the larger organic parts of the nitrogen, and the seaweeds will take that smaller inorganic part. So why do IMTA? I'm sure many people are aware some aquaculture operations and just aquaculture in general can have a negative connotation and just not the best reputation due to operations that don't do things in the most environmentally responsible way. And that hurts, the industry as a whole. So a lot of places are starting to consider this IMTA approach because it doesn't, negatively impact the environment, and it's not destructive. It's also just, I guess, the more responsible way to do things. But not only that, you get multiple products that you can sell from this one system. So you can sell the trout, you can sell the blue mussels, you can sell kelp. So rather than just finfish, you have two other products to sell. And it certainly, with the permitting process, it makes it a lot easier when they see something like this rather than, oh, you're just trying to do, fish and pump a lot of feed and potentially cause some issues. So UNH's approach, and Michael started out with, they want to do something small that is easy to manage, and they wanted to do it in a spot that's not going to be conflicting with any of the lobstermen or any sort of fishing grounds, because that's the biggest thing. So at the same time, though, with this grant, we wanted to incorporate the fishermen and have them help out with this project and engage with them, because ultimately the goal of this project isn't necessarily for super large scale, commercialization, but this is more of like kind of a niche system that could be in these coastal protected areas. Certainly Maine has tons of these nice little coves and bays that are nice and protected, which are really ideal for a system like this. And so once this system's up and running, it's not tons of maintenance as long as things are going well, which usually they do. So it's something that a goal would be the lobstermen could do either as a supplemental source of income and just not really interrupt their main, fishing hours and way of life, because sometimes certain seasons close and they might have some downtime, whereas this system could still be up and running. So they would still have something else to do, because a lot of lobstermen are very hands-on and just very busy people and just love doing all sorts of things. So this was, I guess, one of the goals from the very beginning is, we must have this cooperation and working partnership with fishermen in the area and then other researchers and students. So here on the left, you'll see this picture is our IMTA system. So this is the first system that he had out there. So it's just a 2-bay system. Each pen is 14 feet by 14 feet. And then the nets that we would use would be about 12 to 13 feet deep. So initially we'd be having about 3,000 to 4,000 steelhead trout total in the system. So about 2,000 in each pen, sometimes a little lower. And so in order to get steelhead trout, it's a rainbow trout. So rainbow trout is started out in freshwater. That's all from this hatchery up in Ossipee, New Hampshire. So they're raised there, and then we have them truck the rainbow trout down to the coast when they're at about a half a pound size. And then historically, we have been trying to acclimate this rainbow trout first to the saltwater. You can do a direct entry into the saltwater, but you do see some initial mortality with that, which would be expected. So we messed around a few years with doing an actual land-based recirculating system to acclimate them over about a 10 to 14 day period, where we would start. The salinity in the system was about 10 ppt, which is about a third of the full ocean salinity. Then we would increase that by about 2 to 3 ppt per day and slowly get them up to that full salinity. And this worked. It was extremely stressful for myself and my coworker, because we have large volumes of fish on the pier at the coast, and at the time it was happening just towards the beginning of summer. So ambient temperatures were a lot warmer than what we wanted the water in the tanks to be, so we had to have chillers hooked up, which works, but the oxygen systems that we'd have, sometimes with that ambient temperature swing between day and night, it causes the oxygen flows and stuff to change. So all of a sudden you could start almost super saturating the tanks, and other times it might be, oh, it slows down and it's not enough oxygen. So it seemed like a lot more work than needed. So after 2 years of trialing that, we switched to just going back into the straight entry to saltwater. The biggest thing that we realized we needed to change was we needed the hatchery to hold on to the trout until they were a little bit larger. So once you get rainbow trout around 200 to 250 grams, they're through their smoltification process and can handle that jump to saltwater very well. Another thing that we did is there's a special feed that actually has some salt in it. So by feeding that to them up in ossipy while they're in freshwater, it starts the development of, it's called chloride cells in their gills. And this is what enables rainbow trout to go into saltwater. And the second they enter the saltwater, they're considered steelhead trout. So without those chloride cells, they wouldn't be able to do it. So this special feed really helped enable it, and we actually found was a very big boost to it. This past year, we did the first direct entry into saltwater for the last 5 years, because we did that acclimation system, and it worked a lot better this time. We saw almost no mortality. Our overall running mortality for the entire year was 3.8% in one pen, and the other pen was 5.2%. So extremely low, which is what you want to see. A lot of operations shoot for hopefully survival rates of 85% or higher. So we definitely were in that threshold. So going back to the system here, you can see this platform. So the fish are in the center, 2 pens, and then all along the perimeter here, you can see there's these mussel droppers. So we have the mussel droppers, which you can see in that side profile view, and then we have kelp droppers as well around the outside of the system. So it's kind of a neat view from below the surface when you're diving or snorkeling on it. It's just a curtain of mussels and kelp all around these fish in the center. It looks really cool. You get a lot of smaller native fish that end up kind of congregating around the system. You get lots of lobsters and crabs all around the bottom, as well as striped bass and seabirds occasionally are coming by to see what's going on. We've had seals near the system, but luckily no negative interactions yet, which is great. But yeah, it's a really cool system to see out actually in the river. So I've kind of touched on this a little bit already. The whole purpose of the kelp mussels is, again, to remove that nitrogen. So you can see the nitrogen neutral effect is that 3-to-1 ratio. So there's me holding some of the mussels in the middle of winter. So you can see it's just a bulky line that all these mussels kind of attach to with their byssal threads. So the initial lines are just this specialized mesh material that we bought from New Zealand. I think it's called fuzzy rope. And it just is basically, looks like a rope that's had a lot of abrasion to it. So there's a lot of little like fibers and stuff for these mussels to kind of attach to. So when there's a natural spawn of mussels every spring and fall. And so if we have these mussel dropper lines out with nothing on them during that time, they will move around in the water column and then settle onto these ropes. And then once they've settled on, you'll just see them slowly grow over time. They attach to byssal threads, and that's how we get mussels on the line. So as this is more the engineering view of the system. So the IMTA project was designed by a master's student. It was his master's thesis. So it was an ocean engineering project combined with sea grant and the aquaculture aspect of things. So you can see the capacity for this smaller system was 2 tons of fish, roughly, about 5 tons of mussels, about 1 ton of sugar kelp. And it's all made out of the black pipe is HDPE. So It's a nice, it's still a hard, not like hard plastic, it's a softer plastic going by what they consider the durability. And it's all welded. So we have these special cutters and welders. So we were able to do all of this construction up at a facility that had this space to do it. But overall, it wasn't a super complicated process. You have the big HDPE pipes, you just make a cut, you smooth out the edges of that cut, and then you put a hot plate in between the pieces, and it forms this, this bead of the molten material. And then you pressure fit that together. And as it cools, it forms this very strong weld. Doesn't seem like it would be that strong. I was a bit skeptical at first, I'll say, but it holds up very well. The first IMTA system had been out in the mouth of the river there for, I want to say, about 5 years to 6 years, and it never broke, and that's year round. And so at the mouth of the river there, we do get waves up to 10 to 15 feet during really bad storms. And so it withstood all the storms over the years. I think the thing that would go the most would just be a random piece of decking. You know, the wood decking on top there was one of the issues. So we had another generation of the system more recently called the Aquafort, which you'll see in a few slides, which was version 2.0 of the IMTA, a little bigger, a little better. So here we can see this is the whole construction of the IMTA. So it started out in a big warehouse in Bristol, New Hampshire. So everything was cut and laid out and shimmed and level. And then slowly more and more components got added onto the system once we had that frame there. I do the various stringers of wood across the system. It's a little difficult to tell in this picture, but in between these two pipes, there's that inner ring and the outer ring. There's these big, what's called billets, which is a flotation component of the system. So the billets are spread out among this whole inner and outer frame all the way around the system, which provides additional flotation. And inside the HDPE frame, that's also filled with foam too, to provide more buoyancy. And so, you know, it needed a lot of flotation to, you saw the weights in the system. You know, we got 5 to 6 ton of mussels and kelp hanging off of it, which is a pretty substantial load. Plus, you know, factor in the nets and the fish and the drag from the current. The Piscataqua River has, you know, one of the strongest currents in the U.S. and one of the highest ranking in the world. And so that's another challenge working there is, you know, you have to have something that's robust and can handle that tide swing, you know, multiple times a day. So once this whole system was built up north, there was a big flatbed truck, had to get it all the way down to the coast. And then it was craned into the water. And then we had 2 boats, one in the front, one in the back, some people on the system. And we very slowly pushed the whole system out onto the site with an outgoing tide, because it would have been impossible with the incoming tide. So this is just a good map to kind of show you, although New Hampshire has a very small coastline, it is fairly well utilized with a couple different operations. So you can see up in Great Bay here, the estuary and the river, there's a bunch of oyster farms. I want to say that as of this year, there are now, I think, about 15 different oyster farmers that have sites, whether it's in Great Bay or along the rivers. And now there's another oyster farm off of Hampton and in the estuary there, but they're also doing ocean growing oysters now. There's a handful of kelp farms and leased sites for kelp aquaculture here. There's one out at Isle of Shoals, which is also our site. And then a little bit southeast of Isle of Shoals is what was called the open ocean aquaculture site. That was before my time with Michael, but I've certainly heard plenty of stories about it. They had a lot of larger sea station cages offshore where they'd be growing different types of flounder. They grew cod for a little bit. I think they did some black sea bass and a little bit of haddock as well. And these were some larger cages that were they were submersible. So they could either be up at the surface or for storms and stuff, because that's a very fully exposed ocean site. They could be sunk down to whatever depth was deemed necessary to ride out the storms. So that was probably the largest scale operation I think that has happened with Michael and at UNH as far as ocean aquaculture goes. So this whole IMTA system is definitely a lot smaller, but it's a much different take on it. That was just finfish farming, whereas this is that whole more sustainable, environmentally friendly practice that could be more widely distributed, I think, easier than a larger operation like that. There's also some mussel farms here off of Rye, about 3 miles out. There's a mussel farm owned by 2 lobstermen, Pete and Vinny, who I've worked with as well for the last 4 years or so. So they, I believe, are the only actual mussel farm in New Hampshire, and I think one of 2 or 3 on the entire East Coast right now, as far as longline mussels. There's a lot of floating mussel culture and floating cages up in Maine, but not many long lines. So the difference with this long line is it's just a very long header line. I want to say about 500 feet long. And there are 85 to 90 mussel droppers per headline out there. They have 8 of these headlines total. So, in the rough ballpark of about 500 mussel dropper lines. Each of those are slightly larger than what we have on our system, because this is, strictly a mussel farm. So you want to have the most product you can. So those, I want to say, are about 18 to 20 feet long, the droppers. It takes about 18 months or so for the mussels to get up to a market size, sometimes a little less if the environmental conditions are better. Each dropper, we don't know the exact weight. We're estimating based on the pot haulers struggling to get those lines up into the boat, somewhere around 1,000 to 2,000 pounds per dropper line. They have a lot of weight on them. So one of the challenges that we have faced with trying to grow mussels, both on our system and on theirs, is eider ducks. So there are a large population of eider ducks in the area, and it turns out they love eating mussels. So that was our challenge for, I guess, 3 years on that mussel farm, was trying to combat the eider ducks. So turns out, I think I have some slides a little further. I might be getting ahead of myself here. Yeah. So we need to figure out a way to protect the mussels on those dropper lines to keep them from just getting stripped off by these ducks. Because the eider ducks can dive down about 100 feet below the surface, which we also didn't expect. We thought maybe 20 or 30 feet, but yes, we can confirm it's at least 100 feet. So I'll get into that a little more further into this presentation. So again, this is just a nice picture of us working on some kelp lines here. At this time, there's no nets or fish in the water, it's just the platform. So with our IMTA system, our timeline for growing out these fish, we would typically stock them into the ocean around late spring, about April, May, depending on the temperatures. And then we would grow them all the way until about November, December, and we would harvest them then and bring them to market. So we wouldn't be doing a winter grow out. But the mussel and kelp lines do remain on the system year round. So that's always out there. So this is going up to the hatchery up in Ossipee. So you can see here in the left picture, he's just got a tray full of the eggs. So they hatch them out from eggs, and then we'll get them all the way up to that size that we want, right around that 200 gram to 250 gram size. So you can see them with a net of some of the fingerlings there. And this is just going through the whole transfer process. So they have that truck, they can get about, I think it's about 1,000 fish per truckload. So it is a multiple day process. usually, unless we are very efficient and can just get 4 truckloads in a day, but it's a little over an hour drive for them each way, so it's difficult to do that. But all of the trout that we use are diploid, they're all females. And so as you can see in the lower picture there, he's just netting out some of them. So upper right-hand picture is about, I'd say it's probably about a 200-gram fish. So they're about 6, 7 inches long. And that's really the smallest that you want to have if you're just doing this straight saltwater entry. Anything a little smaller, and you'll probably see that, the higher initial mortality, because they're just not quite ready to deal with that saltwater. All of the trout feed is from a company, BioOregon. It's one of the higher quality feed companies. So we're definitely trying to source, the best feed that we can get with them. The better feed, it's a lot more noticeable, the difference in the quality of the fish and how fast they actually grow. So these trout, when we stock them in, we would get them from that half-pound size, and then by the end of the trial, we would have them up to anywhere from 4 to 6 pounds. So they grow very fast, which is cool to see. They grow quick enough that basically if you take a week off or so from work, you can notice the difference in the size, which is pretty cool. So here's another look at the mussel droppers. So you can see that kind of that fuzzy rope in that left picture that I was talking about. That's already got some mussel seed on it. So those are all tiny little mussels. Those are probably about 2 to 3 month old mussels. And so they've settled onto those droppers that we have. And you can see in that picture, all of them, the current's moving a bit, so they're swaying out a bit, but that's all mussel droppers there. Looks like with spat on them already. And so, yeah, as I mentioned, we are lucky enough to have a natural set of mussels here. A lot of places don't actually get a natural set of mussels, so it makes doing mussel aquaculture a lot more difficult. You have to basically pre-seed these lines, whether it's in tanks in a lab or something. And so, that's just another couple of steps to have to do where things could potentially go wrong. So it's really nice to have that natural set where nature does the work for us, which is great. So spawning sugar kelp is another process. So again, we do get a natural set of kelp on the lines. However, it's not always consistent. It varies year to year depending on environmental conditions. So we did tinker around with getting our own kelp to spawn in the lab. It's not too complicated, but it's definitely not just a straightforward thing. We basically, so you have the kelp in the top left picture here, that's mature kelp. In the late summer to early fall, it'll start developing, and spring actually, it'll develop this dark line across the middle of the kelp blades. That's called sorus tissue. So that's the reproductive material of the kelp. So what we look for is we look for these kelp blades that have that nice, really dark defined line that aren't too fouled up. And we would take those into tanks in the lab, and then they will slowly spawn. And so as they're spawning in the tank, need about 12-hour light cycles in that tank, and you need to make sure the water stays nice and chilled. You can see in the lower left-hand picture there's these PVC pieces standing up in the tank. So you wrap this small twine around that PVC spool, the entire length of it. On those spools, we'd get roughly 250 feet of actual seed line. So as that kelp spawns in the tank, all of it will settle onto that twine on these spools. And then you continue to grow, the small kelp on those spools until it's just about 1 centimeter in length or so, maybe a little smaller. And that's when it's about ready. You can see that middle picture on the bottom. That is a pretty much good to go kelp spool that we had. And you'll see on the bottom right there, that's the actual seeding out process here. So all that entails, for our systems, we just have long line kelp systems, which is a single line with an anchor on each side of it and a float. So you take that spool and you stick that headline in the middle of the spool, and then you tie on that twine to the headline itself. And then you just slowly start working your way down the line, and it will unravel from that spool and just wrap itself around that headline nicely. And just as a precaution, every about 5 meters or so, 10 meters, we'll just put a zip tie on the line to help make sure that that twine stays tensioned, at least until the kelp grows enough to develop its holdfasts that really anchor that twine on the line. So here's another side view with, you can see the darker ones are the mussel droppers, and then we also have those V droppers for the kelp as well. So the kelp will seed out in the fall, typically around October, November, and that will be up to size for the market by April, May. It's very much so dependent on water temperature, so it can be a little difficult to predict. Obviously, more recently, we've had challenging times with warming oceans and just kind of unpredictable temperatures, and especially June. So sometimes it'll be ready to go a little before that. With the kelp, one thing you need to be careful of is the biofouling. So as the water warms up, and once you get closer to the summertime temperatures, you get what is called a bryozoan, which is this encrusting organism that will just cover parts of the kelp blades. And as it's on it, it will start to kind of deteriorate in quality and just kind of break apart. You do also get small snails on the kelp, which isn't as much of an issue as the bryozoans. But once you really get the fouling going, then you get hydroids on it and stuff. And once you have a lot of fouling, a lot of places don't want that kelp for human consumption or to markets. So it is important that, for kelp farming, you have your markets lined up, and that time window that you really need to try to get all your product harvested and brought to market. Otherwise, you might start losing some of your product. As far as human consumption, there has been research done on, how useful is this kelp after it started getting fouled? Is it just a complete waste, or is there something else? And I guess they've been looking into animal feeds with it. And supposedly, once it has this encrusting bryozoan on it, it has a higher protein content, which is actually a good thing. So I'm not sure what all the research is on. I saw a handful of articles about it. So that was the initial discovery. So hopefully there is, a more applicable use for that. So it's not just going to waste. I guess one benefit of it just being on the lines, though, you may have seen some headlines in the news about kelp absorbing CO2. So a lot of operations, not a lot, there's a couple operations that are just growing kelp and dumping it down towards the bottom of the ocean as they're, helping to fight climate change. So there's data showing that it does absorb a lot. As to how useful that approach will be, it's kind of up in the air. There's mixed things on, but hopefully that could be another use for it, just in case the kelp market is inundated with growers, which is an issue that I think Maine is facing right now. They have lots and lots of people that are growing the kelp and want to grow it because it is very easy to grow overall. It's a pretty hands-off thing. But now it's just, the market's oversaturated with kelp, so they may not have a place to sell it. Atlantic Sea Farms is based in Maine. That's where we'll get our seed for the lines sometimes. They are, I believe, the biggest buyer of kelp in Maine, and that's where we would sell our kelp to. But more recently, with the boom of growers, it's getting more challenging to get a decent price for the kelp through that one outlet. So I think we expect to see multiple other places probably opening to start buying kelp if it takes off more and more. Some other uses for kelp. There's been some research done at UNH and other places. By feeding cows some kelp in their diet, it can help cut methane production for them anywhere. I've seen numbers ranging from 30 to 50 or 60%, which is pretty good. I mean, obviously some more work to be done, but that's encouraging first result. So, you know, there's a lot of, I think, different uses that are still yet to be discovered for kelp and how it could really be a beneficial thing. So that's encouraging for the growers that may not necessarily sell it as a human consumption product, but there might be other outlets as well. So this is kind of a model of our kelp line that I was talking about. So you can see it's just one line all the way across. We have one float, the yellow float on each end, marking the end of the line and where these anchors are. For our line, we used 3,000-pound granite blocks as our anchors, one on each end. It's definitely overkill. You can get away with a lot smaller, but we lucked out with a supplier who had some extra granite blocks, and it's like, sure, you can use them. So as I said, you can get away with a much smaller anchor, but we took the overkill approach to not have to worry about anything happening. One issue we ran into deploying those is the blocks flipped on the deployment and they were upside down in the bottom. So that was something we didn't see happening, but we luckily were able to flip them with divers on the bottom. So the actual growing line here is in between these floats. Those 3 floats in the middle are just a lobster float spread out across this line. The whole purpose of that is just to help maintain some flotation on the line, but also to have kind of markers from the surface for lobstermen or other boats in the area to just say, hey, there's a line here, please try not to drive through it. The line is down about 10 feet below the surface anyways, so there's not a risk of crop entanglement, but it's preferred that we don't have a lobsterman setting pots across this line in the water, which has still happened, unfortunately, but not as much as we thought it might. So at the bottom here, you can see the kelp in that left picture. I would say that was probably taken around January, so about 3 months after we seeded it out. And then you can see that bottom right picture. It's much longer, probably about 2 meters or so in length. The kelp that we have grown, we've seen some of the kelp blades get all the way up to about 4.5 meters. We're talking 12 to 13, 14 feet long, which is pretty crazy that it just grows that quick. Because really, you can see that left picture is probably, again, January or so, maybe even February, depending on the year. And then once you start getting a little bit of nutrient loading in the spring from all that runoff, and the temperatures start coming up a little bit, it just takes off. It really just explodes in growth. So we'll get anywhere from 3 to 4 meter pieces. Densities along this line, I want to say we had, about 30 pounds per foot or so was our highest density. So pretty good amount of kelp. For the actual kelp buyers, they want to see nice big blades of kelp. The actual stipe, like kind of the stem of the kelp, is not really that viable for use. So ideally, you don't have as much control over it, but depending on the environment, if it's a more turbulent environment, more waves and stuff, it seems like the kelp stipes are longer to help that kelp attach to the line and not get ripped off. So when you do this in a lower energy site, you get that nicer product for the market, at least, the smaller stipes, nice wide blades. So it's better for you. It's just more product yield for your line. So switching back to our second generation here, this is the Aquafort. I didn't name it. I think it was my boss or someone else. Not sure how it got named that, but it's called the Aquafort. So this is now a 40-ton system. as opposed to our smaller IMTA system. It's entirely made out of HDPE. And so the old pens were 14 by 14 feet. These pens are 20 feet by 20 feet. I'm sorry about that. So they're 20 feet by 20 feet. The initial location for this system was going to be out at that open ocean aquaculture site I showed you on the map. So a mile and a half southeast of Isla Shoals. So that was going to be an open ocean site where we were going to have 50-foot deep nets on this system and be able to grow roughly, I think we're shooting for about 12,000 steelhead trout as opposed to 3,000. We ran into some issues with permitting and getting that site permitted out there. I'll get into that in a little bit. Just one of the barriers for aquaculture can be permitting. So instead, we swapped out this system with our IMTA system. So it's just a bigger system, still in shallow. And the only change for us was that we couldn't do those 50-foot deep nets anymore. We had to go to something smaller because at our site there, it's about 35 feet deep at a high tide. Low tide, we get around 24 feet to 25 feet. So we ended up doing, it's an 18-foot deep net total, but we have 3 feet of that net above to the top of the handrail there. So it's only about 15 feet in the water, but the pens are still bigger, so it's a 20 by 20 instead of 14 by 14. So we were still able to get in just about 7,000 trout this past year between the two pens, which was great. We basically doubled what we were doing before. As far as the construction process, it was very similar to the IMTA, just bigger. The HDPE pipe was a little larger. We had to have a tech come in from Georgia. He flew up and helped with all the larger welding. But other than that, it was a pretty similar design overall. One change you'll see in that right picture is the fiber grate decking. So that was the upgrade. As I had mentioned, that wood decking didn't seem to hold up too well. And in the winters specifically, we would get ice buildup on it, a lot of it, and more so a safety hazard for us and visitors to the farm. So with that fiber grate decking, there's spaces in between, it's got a really good grip on it. And so far we haven't seen any significant ice buildup, which is wonderful. On our old IMTA system, during some of the real bad cold spells we had, sometimes a foot of ice on that deck. And so our entire system would just be leaning. So we'd have to go out in the middle of winter and hammer it all off and, prevent it from doing damage to the system. So as far as deploying the system, it was similar. We had a big crane truck again. We worked down in the Port Authority space in Portsmouth and then craned it into the water and pushed it up the river to the UNH pier. And then we, again, slowly, cautiously brought it out to the site and swapped it with the IMTA system. So I'm going to play this video here. I'm hoping the audio works. I'm going to unplug my headset so you guys should hear it. I guess, Doug, let me know if it's not working as well, and we'll figure that out.
Sure. Just for everyone, I'm going to put the link to the video on YouTube. It's here in the chat, just in case you want to save it for later.
There's great potential in the United States because we have so much water that ranges from American Samoa and the Pacific to the Virgin Islands that are federal waters that could be farmed. Just offshore of Newcastle, we have a small site that grows sugar kelp, steelhead trout, blue mussels, and this year we'll have a few sea scallops. Early on, when we were trying to grow fish here, our experiments were focused on trout behavior. Fishermen would stop by and say, "Hey, what are you doing with those seed pens? What's in there?" And we'd show the trout. That's where we decided that this might be something for them.
I'm Ward Byrne. I'm the captain and owner of the vessel Sugar Daddy. I lobster fish, I tuna fish, and as of the past 2 years, I've been the UNH entry. I had no idea what I was getting into when I
Can you pause it for a second? I don't know if there's something we can do to improve the sound quality.
Yeah, is it not so great right now?
We missed what that second fisherman was saying.
Oh, okay. I could try bending the laptop screen down a little bit. It might help it pick up the sound a little more, or
Yeah, maybe is the volumes like all the way up and things like that.
yeah, let me try just shifting it a little bit here. Just let me know in a second here if this is any better. I'll go back a little bit on the video here.
Maybe the captions. That's
Oh yeah. I apologize. I thought I had this. Okay.
Yeah, somewhere right.
What about here? Okay. Hopefully this works.
Thank you. The audio cut out for most of that, but I think the visual components are important to take in there. I was
Okay, I'm glad it kind of worked.
How long has the aquafort been in the water?
So the aquafort has been in the water. Let's see. This would be the third summer. I'm trying to remember. COVID has made it difficult. I think this would be the third summer it's in the water. We were supposed to do an initial grow out that summer. We put it out, but then COVID was starting and permitting stuff got delayed. And so we ended up this past summer was the end of our second harvest in the system. So let's see. Pick up the next slides here. Skip on. So I'll leave this as the background so you can see the system. So with this larger system here, one of those changes, as I had mentioned, was so our typical grow out had been springtime to late fall or December, we'd harvest them, which worked for a bit. But as we've been seeing these warming temperatures, we've struggled with it to not have mortality. So steelhead trout are similar to salmon in the sense that they need cold water. As the oceans have been warming up here along the summertime, you're seeing lots of temperature spikes that we would never see. So, you know, especially even this past summer, we saw, I think at low tide, we would get temperatures sometimes up to 24 or 25 degrees Celsius, which is pretty close to 70 degrees Fahrenheit, which is just unheard of. I mean, you know, when I first started working for Michael, you know, 6 years ago, even, you rarely would see temperatures hit 65 or so in the summer. That doesn't seem like a big shift, but for a cold water species of fish, that is a fairly big shift. Also, because at our site, we're at the mouth of the Piscataqua River. With those tidal fluctuations, we'll get temperature swings every single tidal shift. Sometimes that'll range, you know, in the summer, it could be at 16 degrees Celsius at one tide and then go all the way up to 24, 25 Celsius at the other tide. You know, so that's a very substantial temperature swing for fish to have to endure multiple times a day, every single day. So after a few years over the summer of just, you know, struggling with this, we still had decent survival, but it was noticeable. We were like, okay, how can we overcome this? You know, can we adapt this fish here? Do we need to switch species? So we came up with this aquafort. We were like, okay, so how about a winter grow out? And it was something we had all kind of considered, but I don't think we fully wanted to necessarily do it. It's just, you know, winter time up here on the ocean is not the most pleasant. It comes with its own set of challenges. both for our safety and for the fish. But we were like, okay, well, let's think it through and try to work this out. How realistic is this? And we looked at historic data for the temperature and all this, and both weather and water. And we're like, we think we can do this. The lobsterman, luckily, was able to keep his boat in the ocean all year round, which was great because it's just a lot more safe to be going out on a larger vessel in the wintertime, having a couple other people out there just for safety. And so we stocked out the fish, as the lobsterman said, late October, October 21st, I think. And they luckily were able to be even larger from the hatcheries. They were probably close to 250 to 300 grams, which allows them to handle that saltwater even better. So we stocked them out, and we were shooting to have our harvests all done by June, but things got delayed again, and our last harvest was the end of August, which had us very nervous because July and August are when we really see those warm temperatures. One interesting thing that we saw by stocking these fish out in October, by the time those warm temperatures came around, these fish were 4 to 6 pound fish. So they're much more capable and just able to handle those temperature swings. We weren't sure if that would be the case, but it certainly seemed that way because we did not get those large mortality spikes. As I mentioned, we had 3% mortality in the one pen and 5% in the other out of 7,000 fish total. That's awesome. And so we really think by doing that winter grow out, the fish are able to be in the ocean. They're very used to it come the time where there's a little bit more of those temperature swings and things that are going to stress them out. They're just more readily equipped to handle it. So I would say our one challenge with this larger system, we ended up harvesting, I think, just shy of 16,000 pounds of trout at the end. Majority of it was sold to markets in Portsmouth, but then we've been partnered with Row 34. You may or may not have heard of the restaurant chain. They're based out of Boston. They have a location in Portsmouth, but the owner and chef, Jeremy Sewell, is very much so all about local, sustainably grown everything. I believe their model is for the restaurants, they want to have everything sourced within, I think, 30 miles or 40 miles of each location, which is great because that's what you need for a system like this. We're trying to provide a local, sustainably grown product, and we want to sell it to somewhere that's going to, advertise that and promote it and be in sync with it, rather than somewhere that may not necessarily care as much about where it's grown or the quality. So that was a big component, I think, for having this project be successful, is finding that partnership, with on the market end to make sure it's going to a good place. So they were able to help us with a much larger quantity of fish this year, and helped distribute fish down to Boston, Red's Best Market down in Boston. And so that was helped us with that burden of, we went from having, let's see, with 3,000 fish, I think we'd have about 8 to 10,000 pounds total. It was a pretty big jump to go up to 16,000 pounds of fish or so. And luckily that helped smooth things out for us. But even with that, there were times where the market just wasn't quite able to handle the volume of fish that we needed, which is why it dragged out to August instead of, we wanted to have the fish out by June, and not deal with that temperature swing, which I guess worked out in a good way in the long run, because we saw what happened with the fish with that temperature swing, and we were actually very encouraged that they could handle it and we didn't have that die off. So I think this could be our new model for how we want to do things now with these warming temperatures. So it seems like we're going to be sticking with the winter grow outs. So in addition to it just being a working platform for us, we use it for a whole bunch of different things. We do tours on the system, whether it's students or faculty, researchers, industry partners. So you can see a whole bunch of different pictures here. Row 34 staff, they come out. They used to come out a lot. So that was cool. I think it's a lot of people who may have mixed opinions about aquaculture, which is understandable, come out to the system and might be a little against it at first and stuff. And I think I can confidently say that everyone that's been out there has walked away from it and been like, wow, this is a really cool system. Like, this is the way that things should be done. And then there wouldn't be as many of these negative associations with aquaculture. We've had some pretty well-known critics come out of aquaculture too, and we even were able to sway his mind on it. And he ended up writing a very good article about it, which was awesome for us. We were a little nervous at first, but even he came around to it. So that was good to hear. A lot of the fishermen are also supportive of it. And so I think a big part of that was, we wanted to have them involved from the start. Obviously be very transparent with them about everything and say, okay, we need feed schedules, we'll need help with this and that and whatever else they wanted to be involved with. And the site selection. So as I said, we picked a spot where we talked with them. We're like, okay, so where could we go that'll work for us and also work for you without, taking some of your areas that you like to fish or put lobster pots, because we don't want to have any, issues with you guys or step on your toes. And I think they definitely appreciated that a lot. And that has helped minimize any negative interactions with fishermen. So that's definitely an important part with any sort of ocean aquaculture site selection, both from permitting standpoint, but also really know what happens in that water area where you're trying to go. Because if you pick a spot that is going to cause issues, it's going to make it very difficult for you. They might try to sabotage your system when you're not out there and stuff. So those are all concerns that we had to kind of navigate through and figure out ways to mitigate. So a lot of what we're doing more recently is developing whale-friendly aquaculture gear. So this is getting into the whole, as I was saying, get into barriers of aquaculture. One of the biggest issues right now is marine mammal entanglement, whether it's aquaculture or just anything going into the ocean. If there's a line or a chain or anything in the ocean, it's very, very difficult right now because of that risk of marine mammal entanglement, which again is understandable. No one wants to harm whales or do something that could harm whales. So it unfortunately slows down the permitting process for any operation and makes it very difficult. So a lot of the more recent research we've been doing is, figuring out how can you, reduce lines for mooring systems or just in general. How can you construct them and deploy them in ways that wouldn't pose any risks to whales should they ever be near the system. Luckily for us with the aquafort, with the mouth of the Piscataqua River, there's no whales that ever come in there. But they still held us very, they held us accountable for everything and said you need to treat it as if there could be whales there, which, again, is completely understandable. And it's a good practice for us to make sure we have, what would be okay to put out in the open ocean, even where we are, because it makes that next step, I think, easier. And the permitting agencies, I think, are more comfortable with that next step if, you can demonstrate, okay, it's been at this site for a while. These are the steps, whether it's mooring equipment or video monitoring systems you can see in this right picture. Various things that you're doing to really be proactive about it rather than reactive. So this camera system you see here on the right is actually on our system right now. It's from a company called Synthetic. If you look them up online, you'll see it's a very large company. They're based out of the West Coast. They're demoing this system right now. So you can see there's 2 cameras on it and a battery box. And so it has a hydrophone that's hanging down in the water about 12 feet down. And so they're listening for any noises, specifically, whale noises that are going to trigger the system. to then start recording with those cameras. The whole purpose of this, or the concept is, so if you have a system out there and whales are detected, it's going to start recording right away and continue recording until it doesn't hear that anymore. It's all live feed. You can see it, I guess, from your phone or computer back wherever you are. They're able to view it from the West Coast, which is pretty cool. So that instantly, you can have it set to kind of set off that alarm, like, okay, there's whales in the area. We should either get a boat out there and just have people out there in case, or at the very least, we know there could be something happening nearby. That's their concept of it, to help operations be, again, more proactive versus reactive. To date, I don't think there has been a single right whale entanglement anywhere in the Gulf of Maine in fishing or aquaculture gear. I think the only one has happened up in Nova Scotia recently with some crab fishing gear. So, there's been ship strikes and stuff with right whales. So I know they do shift the shipping channels depending on certain times of the year to help with that too, which is great. So luckily, nothing as far as we've heard from the agencies has happened yet. So that, again, they just want to be very proactive about it and prevent anything from happening, which is definitely the way to go with it. But certainly a lot of lobstermen and stuff are very vocal about opposition to a lot of these regulations that they have to deal with, which, it's understandable. Some of the restrictions are pretty harsh for them, but, it's about adapting and, changing your ways to still do what you need to do in a safer way, which I think is important. They had a large vertical line reduction, I think upwards of 50 to 60% reduction in the number of vertical lines. And because I think lobster pots are probably a lot more hazardous for whales than, like, say, our mooring system lines. The reason for that being, lobster floats are not highly tensioned. They're just floating on the surface. They have that line, which isn't tensioned. And so if the whale comes into it, it can wrap around and get tangled in it. With mooring lines, especially if you do a larger diameter rope, they're highly tensioned such that if anything ever did come into contact, there's no way it could wrap. It's highly tensioned. If anything, it would deflect. And that's what the permitting agencies have even said. They said you need highly tensioned lines of a certain diameter to prevent that. So luckily that vertical line reduction doesn't apply to us necessarily because we don't have many lines in the water, but for the lobstermen it does. And so how that impacts us is when we have to have public hearings about our system and stuff, they are very heated about it in the sense they're like, oh, so we have to be reducing all of our lines. How come you're able to put this system in and stuff? And it's not the same at all, but it's, we need to explain that to them and be like, okay, look, we have 2 mooring lines total. It's 2 lines out versus, some lobstermen can have 500 to 1,000 traps. And a lot of them do, maybe 5 to 10 trap trawls, and then there's 2 or 3 floats on each one. So that's a lot of vertical lines. But in their mind, it's like, how come you guys are able to skirt around that and we can't? So that was another, important thing about us working with the fishermen to try to, we can help voice some of their problems to the permitting agencies too, who we work closely with, and just have a good relationship between kind of a little like 3-way triangle there, which I think is important, especially with everything being so volatile and changing. So let's see.
We're about 15 minutes to our end time, just a time check.
Okay, perfect. So going back to the local markets, we would sell to the seafood markets here, and luckily we could get upwards of $6.50 to $7 a pound for the trout, for price that we get. The markets, when we went into them, would actually have the trout marked up to the same price as their highest quality salmon, which was pretty surprising, upwards of $20 a pound or so, and people were loving it here. They would sell out of the trout every, every week or two that we deliver it, they'd be like, okay, when are you guys doing your next harvest? Smaller volumes, which made it a little more difficult to manage than say row 34, who's able to distribute. You know, we could harvest 2,000 pounds a week and move that, as opposed to 200 or 300 pounds a week. Mussels, you get a lower price, and kelp is the lowest price. And that's just due to, you know, a lack of a market really being developed enough, which I think will continue happening in the future here as there's just a larger number of kelp growers. The one cool thing around here that we do is there's Portsmouth Brewery makes kelp beer out of the kelp. They've been doing it every year for, I think this is year 4 now. It's called Selkie. So that goes on tap around like June or July. It doesn't last long. It's become a fairly popular thing. That's just a cool little use for kelp that I don't think we anticipated. So that was interesting to see. So as far as the economics, that's the big thing with the system. So the whole purpose of scaling up was to make it to the aquifer was to make it a more, I guess, viable system. So based on this, it's more attractive to lobstermen. You know, if you have too small of a system, they're not going to care to even put in the time to do it if it's not worth it. So by going to this larger size, it made it a lot more friendly to that. And they're still running the economics on some of the full grow outs with that full deep net, because we had to scale back, unfortunately, to our 15-foot deep net instead of 50. So there's a big difference in the number of fish you could grow. But things to consider for it, obviously the cage size and net depth are going to greatly impact it, depending on the number of fish you can have in it. And then just the feed cost is very high. Aquaculture feed's not cheap, which can also help, I guess, in any arguments where some people say, you know, you're nutrient loading the waters. A lot of operations don't want to just pump feed into the water uncontrolled because it's very expensive. It's often one of the highest costs of an operation. So by just wasting a whole bunch of feed, which isn't good in general, not only could you nutrient load the water, but you're also just losing money. You're hurting your own business. So as far as us with feeding, it's all visual. We feed until the fish are satiated. They do show some visible signs. And we also have cameras at the bottom of the pen to make sure that no pellets are going through the pen uneaten. And if we see any pellet start getting close or to the bottom, that's when we cut feed and we're like, okay, we're done. So that's definitely an important consideration. Both the feed costs and the fingerling costs. You have to pay for the fish from the hatchery, labor, depending on what site you pick. If it's far offshore, then you have to start factoring in, you know, boat costs, fuel costs, all of that stuff goes up a lot the further offshore you get. So that's why this system in general, we think, is much better adapted to just that near shore protected coves. It's closer for the fishermen, it's more convenient, especially come harvest and stuff. Then you'll have to be transporting product from as far. And it's, so the system itself is a lot stronger than the previous one. It's built to withstand 30-foot seas, which most places along here you're not going to see if you're in any near shore protected area. But with our open ocean site that we were going to put it at, we had to design it with those circumstances in mind. Because you do at Isle Shoals occasionally during bad winter storms see close to 30-foot waves. And then, yeah, as I said, you know, vessel fuel, but also insurance can be another cost. It's, I think, a developing thing as aquaculture starts taking off more in the US, because I don't think it's something that companies had to previously think about as much. So I think it's still kind of a developing area as well. So as I've touched on this already, this winter grow out seemed to really be the way as far as mortality and just the growth. We hit 2 really good growth periods, one in the fall and the spring, kind of when the temperatures are right in that sweet spot of about 10 degrees Celsius or so. 6 to 16 degrees Celsius, I think, is ideal for them. And then as well, so with the nets in the water, you get biofouling on them. So we have to stay on top of cleaning them, which involves myself or my coworker jumping in the water and spending hours on end with a pressure washer, blasting out the fouling. And then as well, so sea lice is just a little ectoparasite that is on fish in general, like cod and haddock and stuff. So you do see some on the trout, but typically in that really warm period over the summer. So that's another reason we were kind of straying from having to worry about that by doing the winter one. And we did see far fewer lice counts on the fish. We had a graduate student monitoring that for part of his thesis the last 2 years, which was cool. It was valuable for us and valuable for him. So that involved, netting out the fish, giving them a 1 minute freshwater bath, and the lice detach during that 1 minute. Then we can sieve out that water in a graduated cylinder and a filter, and then count all the lice. So that's to put it in the short term. But it was interesting. It was cool for him. It was his thesis, but it was also very valuable for us and other industry people who were considering this. I've, I think, touched on a lot of this, but I'll go through things that I haven't here. So for considering IMTA, the biggest thing I think is navigating to a site that permitting agency is good with, but especially the fishermen. Developing whatever cage and mooring grid that you want. And then a big thing is your containment plan for a big concern could be escapees if something happens, depending on the fish, since ours are all diploid female fish, and steelhead are still present in the river. Fishing game isn't overly concerned about. Obviously, if something happens, we have to report it immediately and then talk with them about next steps. It hasn't happened, so we haven't had to deal with it. And then I guess considering where you're going to source the fish from, luckily we have our hatchery an hour away in the same state. So it makes transportation of fish a lot easier. Once you start crossing state lines, it can get complicated with different fish and game departments. And then figuring out, your grow out plan, how many people you need, vessels if you need them, how much feed, scheduling your harvests, making sure your market is lined up before you really jump into this, because you definitely need to have some sort of buyers lined up and be like, okay, this is where we're going to move our product and not be stuck sitting on fish through the summer like we unfortunately did with some of them. But again, by doing this winter grow out, it was okay, which is good to know for the future. And then funding can range from grant stuff, which is how I think my boss is trying to go about this. Any interested lobstermen or people can work with Sea Grant or other institutions, I'm sure, to secure grant funding to help as a baseline for this before really taking it into their own personal investment. I think we touched on most of this. So yeah, the Aquafort was just that expansion of the IMTA model. I think my boss would love to see the same system, down in the Gulf of Mexico and these Caribbean islands, where you can do a nice small system without having a huge impact, but still be producing a local seafood product that can be sold to markets there. Because that's where the system is really suited best. Not supposed to be that massive industrial scale farming. And that's how it works, I think, the best. So depending on locations for where people would consider this, it doesn't have to be steelhead, trout, mussels, and kelp. It'll change depending on where you go. So shellfish that you could use might be oysters for taking up nitrogen. If you're down in the Gulf, you could use Gracilaria as your seaweed instead, potentially sargassum. Fish species, there's a whole bunch that you could do if you're in warmer waters. I'm not even familiar with the full list, but there's a surprising number, which is pretty cool. There's like pompano, there's triple tail, there's jack, there's snapper, So a whole bunch of different things that you can mess around with depending on where you are. And again, you have to consider, where can I get these juvenile fish from to stock out the farm. I just touched on that here with the Caribbean one. And I've talked a lot about these challenges. I'll just briefly run through them. So eider ducks here, you get to see a lovely picture of our nemesis with the mussels. Yeah, permitting is, I think, the hardest one with marine mammal entanglement stuff. So the easiest way to try to deal with that is just being very proactive, working with the agency and trying to figure out how to best mitigate anything from happening. As long as you're actively working with them and trying to problem solve, I think that goes a long way with them. And then they're going to be a lot more helpful with you rather than just brick walling you and shutting you down. And then getting your license through Fish and Game, import permits and stuff, which isn't overly complicated as long as you're doing certain species within state boundaries. It can get more difficult if you're crossing state boundaries. Not to say it's impossible, but it is definitely extra steps. And obviously the biggest challenge now is the increasing temperatures in the Gulf of Maine, which I guess we'll see how that continues. I believe we're on the last slide here. So I guess a unique thing that has helped us with working around UNH is we just have so many different things that all kind of work together to make this happen. So we have a big ocean engineering pool on campus where they did the initial modeling of the system small scale and created the wave pool to simulate the environment out offshore and do all the modeling and really try to work out anything that could go wrong before we even get it into the ocean. And a lot of the people that work at the coast here have had years of experience getting these permits and stuff. So they're familiar with the path already and familiar with a lot of the contacts in the agencies, which helps. We have a lot of biologists, being associated with the university, which is great. And Portsmouth with all the local fishermen and stuff, tons of industry partners. So it all works together really well when we tie everyone together and try to make this happen. And for the future at that open ocean site, they're establishing, so it's a 50-acre permitted zone is their goal. And that's to test out whether it's aquaculture systems or offshore wind or anything that needs a permitted site. By having this established 50-acre zone, they can skip that initial permitting process because it will be zoned for all of the above, potentially to be deployed there, to be tested before actually getting brought to the industry to problem solve it. And that wraps us up with this presentation. I ran a little longer than I thought. I was going to touch on some shrimp aquaculture, but we have a nice handout on it that we could probably distribute, whether it's in the chat. I don't know if that would be the easiest way, Doug, or
yeah, that'd be an interesting handout.
Yeah,
I'll link into the chat. There was one question, I think, specifically on the costs around construction for your tanks.
Okay, for the aquafor.
Yeah, maybe you want to say the aquafor, or if you know a little bit about the differences in between the two.
Mm-hmm. So the IMTA was built before I got here, but I want to say, I think Michael mentioned the initial construction of that smaller system was around 38 to like 45,000 or so for all the materials. The aquafort, I think, was closer to about 70,000. But with that larger system, things to consider are that increased volume of fish, more mussels, more kelp, so more product to help recover that cost quicker.
And do you think the larger model would stay out longer? Would be, what would be 10 years, 20 years?
Yeah, so it can stay out however long you want based on your permitting. So I think a lot of permits, as far as I'm aware, our permits, I think, need to be renewed every 5 years. Depending if you're zoned as a commercial area, which I think you would need to be, it's probably a similar 5, maybe even 10 years. Things keep changing as oceans are changing, whale migration patterns are changing, they keep updating policies. But as of now, it's 5 years. It could become more frequent. Yeah.
Cool. Well, I do want to respect all of our time. And if you have other questions, how should we, continue to follow the work that you're doing at UNH and so far?
Certainly, you can email me any questions you have. I can put my email into the chat here.
That'll be helpful. And also, it's in the program for
okay.
folks who can find you there. Cool. Great. Well, thank you again so much for all that information. It's great to see what's going on there and how it could be scaled up into different places.
Yeah.
So as we wrap up, I want to make sure that you all remember to fill out our evaluation. I'll drop that right down here in the chat for you. It helps us make our events better and improve our content. As well, we want to make sure that you check out our vendor marketplace and show your appreciation for their support of NOFA Mass. Also, we have our live auction that's going on online right now, and it wraps up tomorrow at 6 p.m. So be sure to check those items out. As well, this is the last session of the day, but we'll be back tomorrow at 11 a.m. with our keynote, Precious Fury, who is going to just inspire us all to continue the good work that we're doing together. And then we have 2 more sessions tomorrow that will be larger collaborative sessions. So I hope you come back for those. Again, make sure to keep your program book because it has the presenter contact information and other good stuff. Of course, the links to the next sessions. So with that, thank you all for attending this workshop. Thank you so much, Eric, and I look forward to seeing you all next time.
Thank you. For that shrimp handout, how should I attach?
I think I have it somewhere here. Where did I see that? What we can do is attach it into the recording as well. I can include a link. Do you have a link to that now that you can put in the chat?
Not sure if it's a link. It's just a PDF. Let me see.
I think I have it here.
Okay.
Sure if it's good, I think I can share it through this, through our Google Drive. So
okay.
Everybody.
Perfect.
Sure. Let me get that back here. Here, yes, this is the. What did you call it? It was a shrimp.
Yeah, it's a biofloc shrimp system.
Bio. Oh,
perfect.
Yeah. Well, thank you again. If there's are there any other questions or anything? If not, I'll just close out for the day.
I think one question there.
I was waiting. I was so patient waiting. Can I just ask 3 quick questions?
Yeah, sure.
Thank you. I'm with NOFA New Hampshire on the side. Thank you for putting UNH putting us on the map and all your hard work. 3 quick questions. Do you use a GMO-free food? Is there vandalism or theft? And does Fish and Game patrol your setup?
Okay, so for the feed, I'm pretty sure we do. I'd have to check the label. If you look at BioOregon online, specifically use their specialized trout feed. I believe they're trying to stray from that. A lot of companies are trying to shift from that. But that is certainly a challenge that the feed industry faces for sure. And something I know they're spending a large sum of money on trying to, modify these feeds to be as good as they can be.
Well, it's required with NOFA. You know, no
Okay.
GMO,
Yep.
in the organic crowd.
Oh, okay, gotcha. Yep.
Vandalism and theft?
So we have had one incident with some lobstermen. Ever since then, we have signs on the system, saying 24-hour video surveillance, and we set up a camera from the Coast Guard station that looks out at the system, all the time. So ever since that, no.
And does Fish and Game patrol it for you?
Yeah, so Fish and Game, we share our harbor with the Coast Guard, Fish and Game, Marine Patrol, and then UNH has their pier on one side. So they launch out of there, and luckily we're right at the mouth of the river, so they pass it anytime they go out into the ocean.
Great.
I think I've heard that they have said, oh, we saw some tourists that pulled up on the weekend, and we went over and told them, you should not be out here. So, yeah.
Thank you. Thank you. And thank you, Doug, for letting me ask questions.
Absolutely.
Have a good dinner.
You too.
Bye.